Okay, welcome to this explainer, where we are going to completely crack the code on Cambridge Mathematics AS and A-Level. Specifically, we're diving deep into Section 3.6, Numerical Solution of Equations. But for the next 20 minutes, I want you to think of yourself as a secret agent. Your mission, should you choose to accept it, is to extract maximum marks from a highly hostile, rigorously graded exam paper before that clock runs out. We are looking at the absolute critical difference between walking away with a standard, middle-of-the-road passing grade and executing a flawless extraction to secure that coveted A-star. Listen, this isn't just about knowing your mathematical formulas. This is a highly tactical operation. Now, we are specifically targeting syllabus code 9709 today, but I need you to know that these exact same strategic principles apply seamlessly across all the major Cambridge math syllabuses. Whether you're taking 0580, 0606, 0607, 0980, or 4024, the examiner's psychology remains exactly the same. In this briefing, I'm going to show you precisely what the examiners are hunting for, what sets off their red pen alarm systems, and how to maneuver through complex numerical solutions with the absolute precision of a top-tier operative.
Now, I want you to really ask yourself, why does knowing the raw math rarely translate to an A-star grade if you don't have a rock-solid strategy? To understand this, we need to look at two typical candidates. Let's call them Alex and Sam. Now, Alex is a walking encyclopedia of math facts. But when asked to find a root using an iterative formula, Alex completely overloads the page. They just dump raw numerical facts, writing out these infinite strings of decimals that literally bleed into the margins, but with absolutely no clear, structured table. There is zero analysis. On the other side of the spectrum, we have Sam. Sam is constantly racing the clock and rushes the extraction. Sam completely misses the specific command word requirements. When the paper explicitly says verify by calculation, Sam just sketches a quick, messy graph and moves on to the next page. If you could see their flawed answers side by side right now, they'd be absolutely covered in the examiner's red pen marks. The tragic part? They both actually knew the underlying math, but their mission strategy was fundamentally broken. They lacked structure.
So to fix this, we will break down exactly what the examiners are actually hunting for by tackling these four core areas. First, cognitive domains. Second, the procedural framework. Third, your new problem-solving system. And finally, we'll review those critical examiner warnings. Let's get into it. Moving right into Section 1, cognitive domains. This is where we decode the actual matrix of the exam itself. This comparison brilliantly illustrates our first core principle. The academic benchmarks for this syllabus strictly prioritize analytical depth over superficial breadth. This is exactly where our candidate Alex compromised the entire mission. Alex tried to show superficial breadth, calculating iteration after iteration, punching numbers into the calculator in a panic, without ever stopping to analyze what those numbers actually meant in relation to finding the root. Cambridge examiners are hunting for depth. They want to see that you understand the why. Why does an iterative sequence converge? Why does it diverge? Let me give you an example. If a question asks you to show that an equation has a root between x equals 1 and x equals 2, you literally cannot just guess numbers and hope for the best. You must calculate the value of the function at 1, then calculate it at 2, explicitly state the change of sign, and conclude that because the function is continuous, a root absolutely must exist in that interval. That right there is true analytical depth, and it's what separates the amateurs from the experts. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, to achieve that depth we just talked about, you have to hit three distinct cognitive domains, proving your logical reasoning: knowledge, application, and analysis. And your absolute secret weapon to hitting all three is something we call the SSSV framework combined with the Peel structure. SSSV stands for State, Substitute, Solve, Verify. You state the mathematical formula, you substitute the given values showing your exact working out, you solve the steps systematically, and you verify the answer by linking it back to the specific context of the question. You can actually overlay this with the Peel framework, point, evidence, explanation, link, which is usually used for essays but is a massive game changer for extended math responses. You make your point about the root, provide the mathematical evidence from your iterations, explain the convergence, and link it back to the required decimal places. Look at the data breakdown. Top-scoring answers explicitly follow this structured, step-by-step logic. It leaves absolutely no guesswork for the examiner. Which brings us to Section 2, procedural framework. I want you to consider this the tactical blueprint for your entire exam extraction.
You absolutely need to leverage the method mark strategy because examiners heavily reward the evidence-based reasoning process, not just your final numerical answer. This is where we start seeing the real transformation. If we take Alex and Sam's heavily red-penned papers and rewrite their answers live using proper SSSV structure, those red marks instantly transform into green check marks. Why? Because by simply showing the explicit substitution of an initial value into the iterative formula before just writing down the answer for the next term, Alex secures a vital method mark. Listen to me, even if your finger slips on the calculator and your final answer is completely wrong, the examiner will still award you points for the systematic process if they can see it. Method marks are your safety net. They guarantee you don't walk away from a highly hostile question empty-handed. You must document your process.
And that brings us to presentation. Presentation follows incredibly strict conventions in Cambridge exams. Applying these professional, operative-level skills guarantees you don't drop easy, unforced formatting marks. Let's look at the appropriate formats requirements specifically for Section 3.6. When you're performing iterations, presenting your data in a clear, linear table with proper column headings is basically non-negotiable. It proves to the examiner that you are tracking the sequence logically. If the question asks for a final answer to 2 decimal places, your clear annotation must show the sequence converging to that exact precision before you round. Our candidate Sam lost 3 whole marks purely by failing to round correctly at the final step, despite doing all the hard, heavy-lifting math perfectly. Do not let sloppy presentations sabotage your extraction mission when you've already done the hard work.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Furthermore, your data interpretation skills are absolutely critical here. You are required to fluidly move from extraction to interpretation to a rock-solid conclusion. In numerical solutions, this very often means looking at complex graphical data, like those tricky staircase or cobweb diagrams. You have to visually extract the starting value, interpret the relationship as the line bounces between the curve and the line y equals x, and draw an evidence-based conclusion about where that root actually lies. This visual representation of an iteration is where the cognitive domains of application and analysis truly collide. It's a beautiful puzzle if you know how to read it. Let's move into Section 3, the problem-solving system. We are now going to build your ultimate deconstruct and evaluate methodology through a quick, interactive workshop. Get ready. This right here is the definitive deconstruct, solve, evaluate methodology you must deploy for complex problems. Let's run a simulation. Challenge 1, data scan. Imagine we've got a complex, iterative cobweb diagram on screen and a 60-second timer counting down. You need to extract the core trend immediately. First, where is the initial x0 value? Notice how the path spirals inward towards the intersection. Does it converge or diverge? If you systematically break this visual into logical steps, you'll see the sequence is spiraling tightly around that intersection point, meaning you can confidently verify that the route is being approached. Step 4 in our system is checking for reasonableness. This is crucial. If your subsequent x values are wildly fluctuating away from the root on your calculation is fundamentally flawed. You need to abort, recalculate, and recalibrate before you waste any more time. To reach that top evaluative level, you must evaluate the quality of your evidence by explicitly identifying limitations. Let's try challenge 2, find the flaw. I want you to listen to this sample paragraph answering a convergence question and find the sentence that is bleeding marks. Quote, the sequence values are 1.5, 1.62, 1.58. Therefore, the root is 1.6. End quote. Do you see the fatal flaw there? The examiner commentary on answers like this is absolutely brutal. The operative exposed a massive assumption. They completely failed to show the sequence converging to a study value to the required number of decimal places before making their conclusion. It was jumping the gun. To secure top marks, you must explicitly state the limitations of stopping an iteration too early. You need to show those numbers stabilizing. Okay, let's step into Section 4, Examiner Warnings. This is where we step directly inside the principal examiner's mind to look at exactly where candidates consistently fail year after year. This quote right here, pulled directly from the official examiner reports, is a massive red flag regarding the mathematical terminology you choose to use. Let's do challenge 3, speed writing. A quick mental speed run. Imagine you have 30 seconds on the clock to write a perfect PEL paragraph verifying the existence of a root between x equals 2 and x equals 3.
Think about the exact phrasing you need to extract those marks. You must state that the function at 2 equals a negative value and the function at 3 equals a positive value. You absolutely must use the exact phrase change of sign, and you must verify it by stating, therefore, a root lies between 2 and 3. If you're writing fast and you confuse the word equation with expression or root with factor, the examiner deducts points instantly. Words matter just as much as numbers here.
The direct tactical fix for this is simple but crucial. Standard operating procedure requires you to explicitly define your terms. You need to confidently talk about the sequence of approximations, the convergence, and the degree of accuracy. A great memory hack, a cheat code if you will, for section 3.6 is to use the SCIR mnemonic. Sign change indicates root. I'll say it again. Sign change indicates root. Having these strict definitions locked into your brain acts as your armor against the examiner's red pen when the pressure is on and the clock is ticking down. Furthermore, you need to ensure you never make these top 3 unforced errors. Number 1 is failing to anchor your final mathematical answer directly back to the specific context of the question. Listen, if the question in section 3.6 requires you to work in radians and your calculator is accidentally set to degrees, mission failed. It's over. That is an unforced error in proper format that costs students entire grades. Number 2, if your presentation is a chaotic scribble rather than a neat, readable table of iterative values, the examiner is simply not going to hunt for your method marks. They don't have the time. And number 3, if the root you are finding represents a physical measurement, like time in seconds or distance in meters, your final evidence-based conclusion must reflect those specific units. Context is everything. So, as we wrap up this explainer, remember that your ultimate goal on the exam paper is to provide justified recommendations born out of systematic analysis. You are looking at the complete mathematical answering system right here. We've got 3 golden rules that guarantee top marks. Rule 1, command word decoding. Always know exactly what verify, show, or calculate demands. Rule 2, the SSSV framework and Peel application. State, substitute, solve, and verify so the examiner can follow your exact evidence trail. And Rule 3, the time management matrix. Don't get bogged down doing infinite iterations if the question is only worth 2 marks. Know when to extract. Now, students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
I'll leave you with this question to ponder before your next tactical study session. How will you adapt your own procedural framework to guarantee you never drop those critical method marks again? When you treat every single question not just as a math problem, but as a tactical operation requiring structure, evidence, and absolute precision, you transform your entire approach to the paper. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Best of luck on your next extraction operatives. We'll see you in the next briefing.